All right, well, welcome everyone to our weekly Wednesday webinar series and Happy New Year. Very excited to start the New Year's off right. And I know I say that every year, but I really mean it. Really setting the tone for what needs to be focused on in our housing stock. And the fact of the matter is, we have millions of existing homes that are, if anything, not just wasting energy, but also causing significant health and comfort issues while they're doing it. And so it is more important than ever that we find out ways to address these issues, to diagnose these issues, to train people to do this, to create the workforce to go out there and fix our housing stock and make these improvements so we can all live healthier, more comfortable while decarbonizing as well. And so that's why I'm really excited about this session. Now, before we get started, I want to say a huge thanks to one of our supporting sponsors, Build Equinox. You know, traditional energy recovery ventilators and HRVs provide basic ventilation, but often lack protection against airborne threats like viruses and wildfire smoke. Introducing the Serve, an advanced indoor air quality management system. It offers energy recovery ventilation along with enhanced protection and intelligent air management. It continuously monitors CO2, VOC, and ensures fresh air is only brought in when pollutants exceed healthy air standards, improving air quality, saving energy. It features a high efficiency heat pump that recovers exhausted air, preconditioning and dehumidifying incoming air, operates in a recirculation mode, provides air purification, dehumidification, and supplemental heating and cooling, has an optional UV light setting, and again has that smart technology for censoring like wildfire smoke for incoming outdoor air quality. So you can visit buildequinox.com to learn more about the Serve and learn about the Serve 1000 for their institutional and commercial projects with higher ventilation needs. All right, this session is brought to you by us, the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. My name is Brett Little, and I am the education manager here. This course is approved, like most of our courses, for multiple continuing education units, including 3 pillars of green and our certified green home professional designation: health, energy, and materials. AIA, health, welfare, and safety, and they make it applicable to your state-based design or contractor license. And then also look out for the 5-digit passive house code that you'll receive as long as you're appropriately signed in and attend the entire session. All right, so with that, I'm excited for our session here, managing indoor air quality. Don't forget the V in HVAC. And a little thing got tagged on there. Ignore that. But with that, I'm super excited to have Bryn Cooksian joining us. Bryn, welcome. Happy New Year to you. Please take it away.
All righty. Thank you, Brett. And good morning, everybody. And Brett, I'm going to request screen share here. Perfect. All righty. Let's get this presentation going. All right. I'll load it up here. And just to confirm, Brett, do you see the correct screen? See the chat here.
I see it.
Okay.
Yeah, sorry, I just didn't see anything for a second.
All right, no problem. All right. Well, thank you. Good morning, everybody. Once again, my name is Brent Cooksey. Brief introduction. I've been in the home performance industry for about 24 years. I'm the founder of 2 businesses critical to the home performance industry. One is a home performance-based contracting business here in Southeast Michigan, and the other is a technical training organization that we run around and provide training like this for our colleagues. So, welcome to again today to this presentation. This presentation is on managing indoor air quality, and we don't want to forget the V. My background is as a mechanical contractor, family-owned business, and I taught professionally for about 15 years at local community colleges. And right now, my days are spent pretty much training, just helping people understand the benefits of decarbonization, energy efficiency, and indoor air quality, which I'm very passionate about. All right. Our learning objectives today, we're going to talk about the IAQ market. From a contractor's perspective, it's pretty important. A lot of opportunities are missed. We're also going to talk about measuring IAQ issues. We're going to discuss what those parameters are, how to mitigate them, and then finally how to solve it using ventilation strategies. All right. This course was compiled and created with help from some very good partners of ours. One is Air Vice, their indoor field guide, BPI Home Performance Institute, their healthy housing principles, and also the Department of Energy's standardized weatherization curriculum. So we want to say thank you to those. All right. So why is this important? Why are we spending our time here today to discuss indoor air quality? Well, it's a pretty staggering stat. When we talk about the EPA, they have produced in writing that we spend about 90% of our time indoors. And the air quality that has been tested is a significantly worse indoors than outdoors. And that's pretty much pretty common across the country, except with the exception of a few areas. So, kind of a general statement, the air quality is about 2 to 5 times worse than outdoors. And the problem is IQ issues are prevalent, but they often go undiagnosed and unresolved. And that's kind of what we're going to talk about today. What are some of these IQ issues and how do we fix them? Now, when we talk about IAQ issues, the goal for any building or residence that we're in is to have clean breathing air. We want to make sure that that air is good for our well-being, and we want to be on the lookout when we're into homes and businesses for things such as mold and moisture, stored toxic chemicals, carbon monoxide, radon, sewer gas, and a whole host of other IAQ problems that are not necessarily good for us to breathe for us and our families. So, what determines IQ? Well, a lot of it could be occupant driven, and there's a link. There's several studies that have been produced where there's a link between energy efficiency or the lack thereof, where a house may be leaky, and there's a link between poor respiratory health. And in this slide deck here, we see that we have a few issues. So looking closely, um, maybe an IAQ issue you may never even realize. If we look here, we see that we have chemicals that are not stored properly. Looking, going to the right, we have mold creation in the attic. Um, Going to the right more, we're looking at an unvented kerosene heater and items stored in a garage, maybe uncapped fuel systems or vehicles. We see a improperly vented exhaust fan. We see an open sump pump, and we see some chemicals that were nicely placed by the return air of this furnace. So IQ is in just about everywhere we go. There's always seems to be an issue, and what we've discovered in our contracting business that opportunities were missed when we were not testing these houses effectively, and that's going to be the basis of our conversation. All right. So common occupant driven IQ sources. Sometimes our pets can contribute with their dander and trigger our allergies and asthma. VOCs, we're going to talk about that specifically today when we have improperly stored solvents, paints, and cleaners. Other unhygienic conditions, such as rodents or insect infestations, there have been links to poor respiratory health and allergies and asthma. Then, what makes matters worse, we are in a crunch to get decarbonization done. We want to reduce our carbon impact to the planet for climate change reasons. Well, when we weatherize a house and we don't do it correctly by adding a ventilation strategy, we could make things worse. And then we have to educate our clients so that they understand that ventilation is absolutely necessary. So, again, that's the basis for our conversation today. So, we take our house and we have our products in our house. We have our allergy medications, we have our inhalers, but is the medicine necessarily solving a problem or is it just addressing the symptoms? And that's what we're going to look at. All right. So customers know the meds, but not necessarily the IAQ problems that are contributing to their symptoms, which could be the reason why they're taking the medicine. All right. When we talk about poor indoor air quality, it's been linked to several illnesses that we may experience, and we may not necessarily understand that it's actually a part of our home or environment that's causing it. Things such as allergies, headaches, fatigue, asthma, flu-like symptoms can all be attributed to some form of indoor air quality issue. All right. So when we look at the indoor air quality issue, it is a $10 billion industry. Again, that is 10 with a B, $1 billion. So customers or our neighbors and our family members are going to large retailers and they're purchasing equipment such as humidifiers and dehumidifiers and stuff like that. And basically they're trying to solve their IQ problem that they know they have, but they're just not certain how to measure it. So when we walk into applications and we see these type of appliances here, we know that there's an IQ problem that that homeowner may be trying to resolve, but they just don't have the data to back up exactly what's causing the issue. So again, it's a $10 billion industry. It's a fairly large industry, and it is a great add-on business segment for weatherization agencies or businesses that are looking to really take building science to the next level. So we got into the market because one of my service techs, I'll say one service tech is probably in about 1,000 homes per year. And if you think about that, that's a huge amount of customers that they're interacting with. And through testing, we found that a large percentages of the homes have a significant IAQ problem. Well, in our business, once we realized that we had that much opportunity, it was a no-brainer to actually learn about indoor air quality and take it to the next level. And specifically for HVAC, every cubic foot of the air inside the building eventually goes to the HVAC system. Well, that's even more reason why we started to pay real close attention several years ago about studying IAQ, measuring it, and actually resolving problems. All right. So measuring IQ, there's a ton of factors that we're going to talk about, and it can come from inside the house or outside, and we'll kind of distinguish those. But the house as a whole, sometimes things in the house can contribute to these IQ issues. So, next, we're going to transition to measuring it and understanding what the problems are. So, big picture, what we want to look at, or the key takeaways, is when we measure IAQ, that should be as common of a measurement as temperature or electrical. As an HVAC technician or energy auditor, if they're running a blower door, measuring IAQ should be very commonplace. Reason why, it determines what type of IAQ issue you have and how bad it is. What's the magnitude? And to get an effective IQ program or robust business segment, you should test on every service call that you have. All right. So here's our process. What we do, we test in. So every single client that we visit, every single time, as part of our policies and procedures, we take a monitor and we test the IAQ. And the particular monitor we use, it gives us 6 parameters. Now, there are other IAQ issues. In our area, we don't have a large radon concentration, so we would address those on edge cases or case by case basis. But for our purposes locally, we measure these six. So we will go into the customer's home or business and we will place a monitor and that monitor will run and we will test in just to get a snapshot of what the IAQ parameters are. And we look at things such as particles, chemicals, carbon dioxide, temperature, relative humidity, and carbon monoxide. And when we get a snapshot, we kind of see exactly what the IQ levels are, and we know we have an established reference point. Once we establish our reference point, then we come up with an IQ solution. So that IQ solution could be a heat or energy recovery ventilator to bring in fresh air. It can be enhanced filtration or maybe an air purifier. And what we do once we solve the problem, we test out. And this is an actual example before the image you saw before and this image are the exact same property after we've implemented a solution. So with IAQ, that's the name of the game. Measuring it, fixing it, and then testing and verifying that you fix it appropriately. Now, when we talk about the test, there are two types of tests that we want to talk about. The as is test is it's a snapshot in time, and it could be influenced by an event, maybe a person cooked recently. So that information is limited, and it may not necessarily help you troubleshoot problems. And we typically like to view this as a service. The long-term test is where I have a deep IQ issue, and I'm going to uh, leave the monitor there and do a long-term test where I'm going to look for more context. It gives me a lot more data. It timestamps information, and it puts the information more into a graphical representation, so I can maybe troubleshoot to see if there's a problem. It also shows me trends. The as is test or snapshot test just looks at a particular period in time, and I may or may not have an IQ problem. But let's say a person's stove isn't working correctly. If I do a long term test, I can actually determine what's the issue, and I can link it to a time frame of maybe that customer or family's activity. We view this as a product. So typically, when customers call for this service, that it is a fee for that we provide the service for them. So those are the two types of tests. Again, as is test, snapshot, okay for baseline. Long term tests a lot better, a lot more information. All right. Again, this is as is testing. It gives you raw data, with no context in it. And this is long term. So this is actually a project that I fixed where the customer was experiencing high levels of carbon dioxide. After we implemented a ERV, similar to the products that Brett mentioned earlier, we were able to deploy that and bring that carbon dioxide level down. And as a result, we were able to track and get instant confirmation that our IAQ strategy actually worked. So this is a long-term test. This was deployed over a couple of days to actually verify that the levels were coming down. All right. Now that we established our testing, now we're going to go into the different IQ parameters that are frequently measured across the country. Again, there are other stuff that's not covered in this presentation. There's not enough time, but we're going to exclude things like radon and other things. But these are the six most common that will help you identify many other problems that we currently face. All right, so first thing we're going to talk about is particles. Now, when we talk about particles, I want you to think about stuff. All right, solid or liquid particles that can linger in the air for long periods of time, and they're particulate matter. All right, they're particles. Now, when we talk about particles, the hazard is if the particles are small, they're more hazardous because they can get into our lungs and they can't get out. They can also get into our bloodstream, and that issue has been linked to all kinds of illnesses and ailments that we contend with. So particles are definitely something that we want to be focused on when we go into our homes and businesses. And particles are bad, but it's one in particular that's really bad that we need to watch out for, and we need to measure. It's not a way to detect it without measurement. So, looking at this image here, this is particles are identified in microns, which is a very small measurement. And to give you a reference point, the human hair is 50 to 70 microns. All right, we can easily identify human hair, but when we talk about particles that are harmful, we're looking at PM 2.5. And what this PM 2.5 is particulate matter of a micron that is 2.5 microns in diameter. To give you a reference point, if we look at the human hair, that PM 2.5 is about that, about this size here. Really can't visibly see that, right? So that particle will bypass our sinuses and bypass our nasal passages in our sinuses, and it will get deeply embedded into our lungs where our body can't get it out. All right, so that's the issue. So sustained particle absorption of that particle size is very unhealthy. So when we measure it, we take a sample size. And what the sample size is, we take a cubic foot of air and we say, okay, how many particles are inside that cubic foot of air? And the measurement comes out in micrograms per meter cubed or micrograms per cubic meter of air. And what this helps us to identify is a concentration of particles. And we have some reference points that come from some pretty well-known organizations, such as the World Health Organization. So they say 35 micrograms per meter cube is the starting point where the vulnerable population, so our elderly and our children, will start to exhibit symptoms from particle inhalation. All right. Again, particle 2.5 is the most concerning, and the EPA even states that the PM 2.5 particle is recognized as one of the top five health hazards. So, just testing for several years, not if but when, every time we walk into a customer's or client's business, there are significant levels of high PM 2.5. So that's why we have to test. All right. So once we see that particle 2.5, like I said, it can get into your bloodstream through your respiratory system. It can irritate the eyes. And some common causes of it is chemical reactions, construction activities, and then emissions from the combustion process, such as an unvented stove. Controlling particles is something that we need to do. We want to look for the source of the particle, and the particle can come from several locations. It can come from cooking, like we just mentioned, air fresheners, combustion appliances, cigarette smoke, cleaning products, and this list is not exhaustive. There's other things that can contribute to particles, but the thing is, we want to identify the source and help to get rid of it. So to control it, source control. If I can remove the particle source from that atmosphere, then that's basically the best offense. If I get rid of that particular issue, source control, that's the best way to handle that. In addition to source control, removing a particle from the environment is another great way to do that. And we can do that by activities such as duct cleaning and duct sealing. We can also have enhanced filtration systems. And don't forget the V, ventilation is very useful in particle control. And we'll talk about that in a little bit. Excuse me. So, eliminate, eliminate, eliminate. Two phrases that we use in our courses often when we're teaching in person courses is to eliminate, ventilate. We use that pretty often to help people understand ventilation is the key, and then dilution is the solution to pollution. Those are two kind of phrases that we help get the point across about ventilation. When we talk about filtration, we're going to put a a air filter, some type of filter media that is designed to remove those particles. They remove them from the airstream, and the reason why this is an effective way to remove particles is because every cubic foot of air that enters a building eventually goes to the HVAC system. So the air goes through there, and that's the perfect spot to remove particles. So before you implement any kind of filtration system, they do have pressure requirements, pressure drop requirements. So you want to verify that your duct system can adequately handle that filtration system before using that method. Um, some of the best things that we've seen in our testing, that MERV 13 and MERV 16 are great choices for removing those particles. But again, the pressure drops are significant. It may not be adequate if the duct system isn't modified. Duct cleaning. What we do with duct cleaning, sometimes the particles are trapped inside the duct system. And if you think about the duct system is fairly neglected. Take an older Detroit house, people update their kitchens, they update their plumbing, they update the actual HVAC equipment, but usually the ducting inside the house is neglected and it's really there for the life of the construction. And let's say that home has generations of families. That duct is, if they're not aware of duct cleaning and that is benefits, they might not necessarily do it. So as a result, duct cleaning is a process where we will go through and physically clean all the duct branches and supplies and make sure that we remove the dirt and debris from the duct system. Excuse me. Um, some people may ask, is it worth it? And in my experience, it is. So, some of the benefits coming from NACA, the National Association of Duct Cleaning, um, you have reduced fan power, where the air handler or thing circulating air uses less energy to do its job. You have increased airflow, increase system capacity. Your system can do more work and it reduces particles. And in an image here, this is a physical job that we've actually done where this was our starting point where we were able to access the ducts and clean them. and this is what it looked after the fact. All right, significant difference. We were able to remove those particles from the space. Duct sealing is also important, and many people will are usually surprised to hear that duct sealing is important, and it is in one particular way. On the return side of an HVAC system, um, if that HVAC system has ducts that are located in an unconditioned space, think unconditioned attic or crawl space, those ducts, and if they're leaking on the return side, could bring in air from areas like the attic or crawl space, which are not great places for us to take air for respiratory health. So, cylinder ducts are a way to help prevent indoor air quality issues, in particular particles, from coming in and causing us some issues. One process that we use is to seal ducts using an aerosol inside, typically since we personally work in the retrofit world. One of the aerosol systems that we use is where we inject the duct sealant inside the duct system. And as it travels through the duct system, it will go and find those leaks and seal it from the inside. And what this does, on the return side of the system, it reduces the likelihood that particles in the attic, such as fiberglass or insects or rodents or something like that, their byproducts, it prevents their activity from getting inside the duct system and making us sick. So this is one way often many people don't think about where duct sealing is also very beneficial. All right. With that, we're going to talk about chemicals. Chemicals. And when we talk about chemicals, we're going to reference it chemicals, but they're really VOCs. All right. So this is our second parameter that we're going to talk about. Now, chemicals or volatile organic compounds. What that means is that they are created from artificial, naturally occurring materials. And the reason why they're volatile, they're typically in a liquid form and they can turn into a vapor really quick. And when they turn into a vapor really quick, they off gas and they off gas at low temperature, so say room temperature. And that off gassing is a concern. Those chemicals can cause us some respiratory issues. All right, so like particles, they can trigger allergies, they can trigger asthma and other respiratory issues. So they need to be addressed. All right. Here are some common particles that we have to deal with. We have chemicals from solvents, adhesive, glues, store fuels, combustion materials, drapes, carpeting, furniture, and cleaning chemicals, and even your clothing. Um, Little known fact: if you were to go to let's say a department store and buy a nice shirt, and you see that shirt and it's well presented on the rack, and you're gonna purchase it, that shirt has been sitting in storage probably for months and it's probably laced with formaldehyde, which is a VOC. And that shirt you bring it home, and let's say you don't wear it immediately and you hang it up in the closet, it will continue to off gas and contribute to those chemicals. So, all these things that we have listed here are issues when it comes to chemicals. And some of the key VOCs that are most concerning are formaldehyde and benzene. All right. If you uh, have been in biology years ago, decades ago in school, we saw that a lot of times animals were stored in this fluid for preservation. And really, formaldehyde is also a fluid that's used to embalm dead people. This formaldehyde is in a lot of our cleaning products. You look at your chemicals underneath your cabinet right now, you'll see some portion of formaldehyde on the label. So it off gases, and it has been known to cause respiratory illnesses. And benzene, which is another very, very common one, that's actually been proven to cause some cancers, and it's highly flammable. So these are household products that you have right now that, as an IAQ specialist, we need to resolve. So the reference point or marker we want to stay below, we're still looking at that cubic foot of air, that box of air, and we're looking at a concentration. So with chemicals, we want to say they're concerned above 500 micrograms per cubic meter of air. And above this level, this is the bad stuff that happens. You see pink eye, nose irritation, throat irritation, headache, and a whole host of other things that you may link to something else or some type of bug or virus, but it could actually be a VOC that's triggering your symptoms. All right. To mitigate chemicals or VOCs, all right, source control, always the best defense. Use products as intended and follow the instructions. Discard partially full containers. You want to discard any unneeded containers. Buy the appropriate quantities that you need and avoid the household concoctions that we make. You don't want to store chemicals without caps or containers. You want to store those bottles inside a sealed container, preferably one with a gasket on it, and maybe set that in a laundry room or somewhere kind of away. And then you want to clean garbage, drapes, clothing, and furniture as soon as you purchase it, and that helps to mitigate chemicals. Now, not recommended from our standpoint are PCO devices. PCO devices are things that can be added to the mechanical system, and they will actually go and destroy um, chemicals. They use a UV light and a catalytic oxidizer. They're installed in a duct system and they break it down into water vapor and carbon dioxide. And the reason why this is our least preferred method is because water vapor and carbon dioxide are also IQ parameters that we're trying to control. Right? Which brings us up to our third one. Now we're going to talk about carbon dioxide. So this is our third parameter where we're going to look at how carbon dioxide affects us and then how to handle it. So carbon dioxide is a naturally occurring element and it comes from us breathing. And as we're breathing, we're exhaling carbon dioxide. Now, the gas itself isn't the issue; it's the amount of it that's the problem. And high levels can create what is called sick building syndrome, where we have fatigue, headaches, breathing difficulties, nausea, poor vision, itchy skin, and it can mimic other things, but it could be carbon dioxide that is actually triggering our symptoms. So, from a reference point of what is considered appropriate, the EPA recommends a maximum concentration of 1,000 parts per million. However, levels above 750 are still a concern. All right. What the higher levels of carbon dioxide mean is that a significant portion of the air that we exhale, that higher level of carbon dioxide, once you start getting to higher numbers, that means that air is being recirculated, and that air that we exhaust will go out of our lungs and into another person's lungs, which is obviously unhealthy. We have a term for that. We call that rebreathe fraction. So high levels of carbon dioxide will trigger a rebreathe fraction where we know a portion of that air, in this case roughly 2.5%, has gone out of my lungs into an adjacent person's lungs, which again obviously isn't healthy. All right. Causes of elevated carbon dioxide. Um, Type buildings where there's a lack of inadequate ventilation, a lack of adequate ventilation, where the building maybe was weatherized and there wasn't a strategic ventilation plan. Carbon dioxide can also come from improperly utilized or unvented combustion appliances. How to manage carbon dioxide? Like we said, we want to dilute it. Dilution is the solution, and to eliminate, ventilate. Using a some type of ventilation device, a strategy that's appropriately sized and installed and commissioned will help to reduce those carbon dioxide levels. Ventilation is bringing fresh air in, relatively fresh compared to inside, which will help to reduce that concentration of carbon dioxide. All right, going on to our next one, carbon monoxide. Carbon monoxide. What carbon monoxide is, it is a silent killer. It's odorless, colorless, and tasteless, and it's impossible to detect without instrumentation. Mhm. When we are looking at carbon monoxide, that's also another IAQ parameter that we need to measure. When we travel into homes, we find that there's two types of carbon monoxide exposures. We have chronic, which are smaller doses or frequent exposure, and then we have acute, which are larger doses or big events. All right, both are harmful, and we'll talk about that here in a moment. What makes carbon monoxide so dangerous? It bonds to our blood um, rather than oxygen about 200 times faster. So our body actually prefers carbon monoxide. And low levels are harmful. And if I'm in that environment of a low level carbon monoxide poisoning for a sustained amount of time, I can get flu like symptoms that could be irreversible. So even low levels of carbon monoxide are not good. So symptoms include headaches, dizziness, chest pain, nausea, and other flu like symptoms. And the effects could linger and they are often misdiagnosed if you were going to get evaluated from it without providing your healthcare provider about specific information. A lot of times, unfortunately, the diagnosis is missed. And then, obviously, if you have the large events with carbon monoxide, then that could mean that somebody can die from it, which is bad. So, the technician or auditor, they look in, they see I need to have two situations to make people inside the home or business sick. All right. First, are the combustion appliances are they vented outside? If it's an appliance that has a vent, such as a water heater or furnace, are they terminated properly? Is the building set up where they're receiving enough air, and are they vented? Are they vented to the outdoors as they should be? And do I have any indication of exhaust gases coming back? The second part of it to have a carbon monoxide event is the appliance producing harmful levels of carbon monoxide. So I need both situations to occur. And that's exactly why in building science and energy efficiency, these are tests that we do just to ensure that these appliances are working properly and that they're vented properly. When you're looking for it, check the following equipment. These are not exhaustive, but you want to look at your gas range. If it's unvented, if you think about using your gas range and you cook in your house, that exhaust gas goes inside the house. Now it's typically not a huge problem because most people only cook for 10 or 15 minutes. You do produce exhaust gases in the house. However, it's not enough time for the dose to accumulate. However, we find problems when people cook for prolonged periods of time, such as Thanksgiving or Christmas, where families will congregate and they're cooking for long periods of time, and then we'll start to see those events take place. So you want to inspect those. And again, you need two things to happen. The exhaust gases need to be inside the building, and the equipment needs to be producing high levels of carbon monoxide. And remember, even low levels are not good. You also want to check fireplaces. You want to check your fuel fired equipment, your furnaces, your boilers, your water heaters, and generators. Those need to be used appropriately as well. Now, even in the air conditioning season, it's important to test. This is right here, a image of a cracked heat exchanger, and if you're not familiar, this is the inside or internal parts of a furnace. And the reason why we have this slide here, the technician that found this issue, they were there at that house for something else. I believe they were there for like a water heater inspection, and when they were doing their testing, their CO testing, using their monitor, they found pretty consistent levels of carbon monoxide. And as they dug deeper into it, they found that the furnace actually had an issue. And they saved that family maybe some health issues because they were able to test. And again, they were not there for this specific problem. So testing is absolutely critical to identify these IQ problems so that you can help, keep somebody from being sick or possibly save their life. If you see evidence of rust on equipment or you see soot, these are key indications that you got a combustion safety problem and that you may have the likelihood of carbon monoxide entering the building. As inspectors or auditors, or just from a homeowner's perspective, no matter where you are, if you see stuff like this is definitely, if you don't have the expertise, to tag in a professional to help assist. Other issues, looking on the left image here, this water heater, they don't come with the flame marks here. That indicates a problem. So, with that being said, testing will help to identify that if you have a carbon monoxide issue. Other things that we look for, the water heater here, see how it's pitching downhill? This is a big no-no. Exhaust appliances are always supposed to pitch upward. All right. In this particular case, you'll see that you'll maybe get low levels of carbon monoxide through testing. In either case, once you find that you have the elevated levels of carbon monoxide, you need to do the research to find out what is actually causing it. It could be a combination of things, like self-inflicted, maybe a customer. cut an access hole in the return air, and they have exhaust gases that are actually coming back from and being overpowered from my exhaust system and being pulled into my return air system. All right. Again, these are things that you capture with testing, and if you didn't test, you wouldn't know that they were there. This is another bad situation. Yeah, looking at this, we see we have the exhaust from the hot water heater coming and traveling downhill. All right, those exhaust gases are going to spill from this piece of equipment. All right, if I have both the appliance making carbon monoxide and the spilling into the house, I can have an event. All right, so once we test to hammer it home, we have to inspect. All right, when we look at our carbon monoxide levels, um, the best advice is to work with your authority having jurisdiction about what's considered high or appropriate. These are just some reference points that you can look at. The EPA says they allow about 9 parts per million for about 8 hours, or 35 parts per million for about 1 hour. Locally in my town here in Michigan, firefighters go on self-contained breathing apparatuses at any instance over 35 parts per million. So work with your local community or business organization to identify your procedures. BPI have a standard, Building Performance Institute, and they say that anytime the ambient CO level exceeds 69 parts per million, that you need to shut down your work, evacuate the premises, and call for emergency services. Right. So those are some of the things that you need to take into account as far as numbers that you need to use for carbon monoxide. Now, this concerns people, and just for awareness, just to help you understand that your carbon monoxide detector, that when you purchase it, they're UL 2034 approved, which means that they're designed to enunciate at 70 minutes, 70 parts per million for 60 minutes, or 150 parts per million for 10 minutes. Now, when your carbon monoxide detector goes off, what that means is you are in immediate danger and you should immediately exit the building. All right. However, these will not enunciate at lower levels. And we have established that lower levels can give you flu like symptoms, and over a sustained period of time, they could be irreversible. So, just something to keep in mind. Maybe to supplement your existing carbon monoxide detectors with one that has a digital readout so you can always see exactly what the number is. With that, we'll go into humidity. All right. Humidity is another IQ issue. It's a huge one from a comfort standpoint, and also it can cause health issues, and it can cause building durability problems if humidity isn't kept in check. When we look at humidity, we have the term relative humidity, which is a ratio, and that ratio is the amount of moisture contained in a sample of air, and is compared to how much moisture that sample of air can hold. So we express that as a percentage, and that gives us a reference point. So watching the news and you hear the weatherman, and the weatherman says 50% relative humidity, you have a reference point of roughly how it's going to feel that day. So the ASHRAE, or American Society of Heating, Refrigeration, and Air Conditioning Engineers, they basically say humidity level should be kept between 35 and 60%, and that also has to deal with the type of climate you're in, and also what mode of HVAC that you're operating in. Right. The reason why we want to keep it in that range is because this is the things that can happen if humidity isn't kept in check. So, looking here, we said we want to keep it between 35% and we want to keep it between 60%. And if you look here in this middle of this chart here, we see that bacteria is more prevalent when it's drier. All right, and then it drops off, and then it's more prevalent when it's wet. Okay, so that range is the best for us. What about viruses? Our business grew significantly during COVID-19 era, because it was discovered that if it's dry, viruses are more common, and if it's wet, they start to get stronger. So that same area gives us the best. When we look at fungi such as mold growth, we see that over 60% If you have moisture at that level in the food source, you can start to get moisture growth. We also see that dust mites, they're more active when it's more wet. Respiratory infections, they're more common when it's dry. Allergic reactions, asthma, they're more common either dry or wet. So we have this sweet spot here. The only thing that and the chemical interactions are more common when they're wet. So this gives us our best range for personal comfort, and comfort also means indoor air quality. The only thing that's not really consistent with the 35 is ozone, and ozone is a concern. Depending on where you are, it's a specific measurement. It's outside the context of this conversation, but ozone doesn't follow that. But for the most part, 35 to 60%, if you're within that range, you limit the bad things that happen with not controlling moisture. Right. Controlling humidity, you want to reduce bulk water sources such as plumbing leaks, open sumps, and roof leaks. You really want to size air conditioners properly as they are designed to remove the temperature and remove humidity out the air. If they're not sized appropriately, they won't control the moisture. You can be closer to that 60% relative humidity mark where you can start to get mold growth. Low humidity is also an issue, and times like now, I live in Michigan here, and it's cooler. Well, if you have an excessively leaky building shell, it will make the air drier because it's displacing all the moisture that's inside the building and pushing it outside due to the difference in temperature between inside and outside. We will purchase a humidifier to put water vapor back into the air, only to have it be displaced again by a leaky building shell. So you want to look at the whole entire house as a system to help understand the IQ issues. And temperature is our final IQ parameter. When we talk about temperature, temperature is critical to determine if a system is operating correctly. Now, many people they may say, "Okay, temperature, I don't necessarily see that one as being an IQ concern," and we get that comment or statement a lot, but it's actually really critical to identify it as an IQ concern. Well, measuring temperature will help us identify other problems, such as disconnected ducts, ducts that may need to be insulated, or airflow issues, which can contribute or compound other IEQ problems. So, in our business, we follow ACA Manual J's process for designing heating and cooling systems to maintain their appropriate temperatures, and we measure temperature as a way to verify that the HVAC system is working. So controlling temperature, our process, we do a load calc where we properly size the equipment to meet that structure's home, to meet the needs of that home. We do equipment specification, and then we do a duct design to make sure that the energy that we size the heating and cooling equipment for that home, it has the ability to get out into the house or building and adequately heat or cool that building. Measuring temperature helps us to identify that the system is working and we're not contributing to the IQ problem by having a poorly designed or operating system. All right. It helps us identify duct issues. If I didn't seal my ducts, remember duct issues, especially in a unconditioned space like a crawl space or attic, and on a return side, bring in particles, and that will also affect my temperatures. My temperature measurement can help me confirm that I do indeed have an IAQ problem. All right. So we went through the parameters and discussed what parameters we want to measure that we most commonly measure and their reference points. And now let's talk about how to fix it. All right. So now we're going to talk about ventilation. And when we mean ventilation, that's bringing in fresh air from outside and it has a diluting effect. It's going to work to dilute it. When we look at diluting it, think about a sugary drink. If you've ever had a sugary drink, or maybe you've had a child and you wanted to feed them something and you added water to dilute it. All right, ventilation has the same kind of effect. It dilutes all the harmful impacts of our IQ issue. And it's really a silver bullet or ace in a hole. It can handle a lot of our issues. Source control is the best, but ventilation can definitely help to control a lot of our indoor air quality issues. All right. And ventilation done correctly is amazing. If you ever been in a house that had an ERV or well ventilated, your well being was a lot better. Right? Now, old practices were where we would try to use the building shell for some type of leakage, and that isn't necessarily the best course of action. The trend now, or best practice, is to have a house as tight as possible, energy efficiency wise, and then have a robust and distinct ventilation plan to help control the ventilation. Right? So we got different ways where a house will breathe. We have wind effect where wind pressure will push air into and out of the building. You have stack effect where air will travel through the building based on a difference in temperature, and then you have mechanical driven um, air that leaks into the building. Well, you can't control any of these things. So it's not appropriate to let a house breathe to attribute ventilation because you can't control which one of these things takes place. And you don't necessarily know where the air is coming from for respiratory health. So it's a practice that we don't do, and what we do, we build it tight and ventilate right. We make our house as tight as possible, and then we have a robust ventilation plan, a ERV, or some type of ventilation strategy that delivers enough CFM to control those indoor air quality issues. All right. The standard we follow is the ASHRAE 62 standard, which is the ventilation standard for residential buildings. And the primary purpose of that is to dilute the indoor air quality pollutants. When you're looking at the standard and you're going to do a calculation, there is a couple of pieces of information you need. You need a conditioned floor area, right? You need the number of occupants, and we identify as that as the bedrooms plus one. And then we use a standard equation to calculate. And really, it goes something like this. We're looking at a house that has about 1,500 square feet of floor area, and we're looking at maybe possibly a house that has 2 to 3 bedrooms. We would want to select and purchase a fan that can deliver that amount of CFM, 45 CFM, to properly ventilate that house. All right, so that's ASHRAE 62. Wherever you are located in the country, you probably have an adoption of some year of 62.2, and to use the most appropriate formula, you want to verify what your organization or agencies to verify which year you've adopted because things do change from year to year. All right. This is a tool. This is a Red Calc. This is a tool from the DOE. And this DOE tool will help you to size your ventilation strategy appropriately. So this is a QR code for it. You can pull it up. And what we'll do, we'll just walk through a brief example of kind of how to use it. I'll give you all a moment to scan it if you like.
You know, that worked out, Bryn, because we actually have a session on this next week. So feel free to give a brief example, and then everyone, if you want to join us next week, we're going to have the DOE on to talk about Red Calc. So
Absolutely. Good timing. Good timing. All right. So a brief example. When you pull up the tool, looking in the right hand corner here, you have to pick which ASHRAE standard you're going to be using. All right. We're going to, in this example, use 2016. All right. And on the right here, these are inputs that you're going to add to come up with the calculations of it. And what this tool is going to do is going to help you, based on your inputs, size the fan necessary for ventilation. All right, so we'll walk through an example here. All right, so on the first part, you have to tell the tool what your building is. Is it new or existing construction? Is it detached, meaning multifamily or single family home? And do you want to use an infiltration credit? All right, what an infiltration credit is, are you going to rely on the leakiness of the shell to assist in ventilation? Again, that's not a practice I like. And the reason why, when you have building leakage that typically is only driven by the difference in temperature between inside and outside. So the building shell leaks the worst or the most when the weather is bad. And right now in Michigan, it's relatively cold outside. It's warmer here in my home. The house is going to leak more than it will, say, in the fall, where the temperature is pretty close between inside and outside. So using infiltration as it has a built-in disadvantage where you're not going to see appropriate amounts of ventilation when the weather is not bad. If it's a mild fall day or spring day and it's really mild, you're not going to get the exchange from that. So, from our policies and practices, we don't use an infiltration credit. So, I just wanted to explain that and why. Looking at the weather station in Michigan, I'm closest to Detroit Metropolitan Airport. That way, I can get some weather data. And then going forward, looking at the left hand side of the screen, I will put the house square footage floor area inside. I will look at the number of occupants, which I will determine as the number of bedrooms plus one. And then I will put in the height of the dwelling. And if I were going to use the infiltration credit, I will put in my blower door number. My blower door number, that's my CFM50 number. And what this tool does is shakes out exactly what the total ventilation rate is and then what fan you'll need to supply adequate ventilation. All right. So you see it right here, it's 32 because I am using the infiltration credit. All right. If I don't use the infiltration credit and I put in my parameters here, the required fan went from a 32 CFM 32 CFM fan to 112, 113 CFM fan. So my line of thinking when I'm designing ventilation strategies, I would then go and purchase an ERV or some type of ventilation tool or product that can deliver that CFM. I have to install it correctly. It has to be properly ducted and sealed and insulated if needed. And I will use that to deliver the air for the home. Again, you see the difference between the two, but just remember the disadvantage of using a building shelf for leakage. It only leaks when the weather is bad. All right, ventilation types. You got the supply only, where I'm going to push air into the building. All right. It affects the building pressures. And there's an energy penalty where, as I push 1 CFM of air inside the building, it's going to push 1 CFM out. The energy penalty means that the air that I've paid my utility company to condition is eventually going to get pushed out my building shell, and the air that has come in to replace it is going to have to get reconditioned. All right, so you get ventilation for respiratory health, but you do suffer an energy penalty. You got exhaust only, where exhaust only affects the building pressures also, and it's also energy penalty. As I push air out, I'm bringing that air in, and I have to recondition it. Now, exhaust only is a little bit more concerning because I don't necessarily know where the air is going to come back from. If I have a leaky house and let's say my attic floor is not sealed or my crawl space is not sealed properly, I could be bringing air back into the house from those areas that may contain fiberglass fibers or something else that I don't necessarily want to breathe. All right, so not my favorites. Those two. Balance is balance ventilation really doesn't affect the building pressures. And when we talk about balance from the standpoint of an ERV or HRV, they recover the BTUs that you paid your utility company and it recovers those or a portion of it and puts it back into the house and it reduces the energy penalty that you will incur by trying to ventilate. um, just to be clear, ventilation is not an energy efficiency evolution. It doesn't have a savings to investment ratio. It doesn't have a return on investment. It doesn't have a payback period. We joke and say that the return on investment is keeping you out of the hospital. So when we look at it, they typically take energy to run ventilation systems, and they're not necessarily an energy efficiency device. All right. Here's an example of exhaust fan. This is you're hanging out in the shower, you turn your exhaust fan on, it's going to pull air out of the building, right, like so. Discharge it properly outside. As it discharges 1 CFM outside, 1 CFM has to come inside. Yeah. Again, you don't necessarily know where it's coming from. It could come from your attic location or crawl space. Right? I really can't control it. Right? Supply air only. Right? I'm bringing in air from outside. I'm bringing it in and I'm going to supply it to my different areas. Supply air only. Again, I'm going to bring in air from outside. 1 CFM in, I push the conditioner out. When I push the conditioner out, I got to pay to recondition it. Right? And this is a form of balance where I have supply, exhaust, and exhaust and air coming in from outside. Balance, but my favorite is the HR and ERV. What these do, they have two fans here. Oh, let me back up. They have two fans here, and they're taking air from outside that is unconditioned, unclean, unfiltered, not proper humidification. It's raw air from outside, and what it does, as it travels into the ERV or HRV, energy is being given up from the exhausting airstream. So the stale air that you have or that you're trying to exhaust has energy that you pay for. It's going to deliver some of that energy into the incoming airstream, so that way you can recover the BTUs that you spent. Again, it's not 100%. There are some losses. However, it's a lot better than completely displacing the air that you have inside your house that you already paid for. So this is my favorite personal ventilation standard. And with that, we'll go through some questions.
Hey, all right. Thanks so much, Bryn. Yeah, we're gonna jump into some questions for those of you who want to stick around and get some of your questions answered. And real quick before we do that, just a quick reminder that yes, this session is being recorded and will be available on our YouTube channel to watch at a later date or time. You can either wait the next couple days to access that when it is listed there, or you can go to our YouTube channel right now, which I'm trying to display but wasn't ready. And it's just Green Home Institute on our YouTube channel, and then you can get updates when it's available. And then for those of you watching this session in the future, not right now, make sure to take the quiz with an 80% passing rate, and then you can receive your continuing education from there. And then those of you here live today, just make sure to fill out the survey, put in your AIA number, and as long as you've been here for the entire CU hour, check your spam for certs at gutenbergcerts.com. You'll receive a certificate right to the inbox, the email you used to register. And you can document that and save it for your certificates. And as always, before we jump into those questions that are coming up, a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, and all of our nearly 400 members. We're so close. Hope you can help us hit that number by becoming a member here today and reach that. And then all of our top tier sponsors who help make many of the products that can achieve these sustainable goals and healthier home performance goals. So anyway, I'll get that pulled up. But there were some questions that came in, Bryn, and certainly of interest that I noted as well on the air quality testing. It's really fascinating because it's just not something we see often when contractors or even quite frankly third party what we call green home inspectors or assessors are going in. Everyone is looking at everything prescriptively, right? They're not looking at what we call performance. So in the energy efficiency world, performance being an energy rating, an energy score, a home energy score, utility bills, but they're looking at prescriptive features of why it's being energy. And so from the health standpoint, people are looking at many of the ventilation systems, as you mentioned, but, they're not looking at what the actual tangible results are. And so, that's very interesting. And so some of the questions that came in around that was just if you would be willing to share some of the equipment you use on the long-term testing. Um, and there was a question here about the monitors, are they customized? Is there publicly available? I guess I'm not really sure what that question was about, but maybe you can just speak to that a little bit more.
Sure. Is it appropriate for me to mention the manufacturer? Brent?
Yeah,
Is that
yeah, I would say yeah, just go ahead and share it and give people
yep?
a sense of what you're using. Yeah.
Sure, sure. We use our monitors are from Air Advice,
Yeah.
Air Advice, and what they that product they have is a monitor. It has those six sensors in it, and it will once you plug it up, it will energize, and it will start to um, it has a pump and the air. It takes an air sample, and after 30
Hmm.
minutes, it produces that as is report.
Hmm.
Um, the long term testing, if you leave that monitor plugged in 48 hours, it will produce a long term report that has a lot more detail, and that detail will be more consistent with time frames, and you'll get to see spikes and other kind of stuff that you wouldn't see with the as is test. So just leaving
Hmm.
a monitor plugged in, I see one of the questions that is leaving a monitor plugged in for more than 48
Hmm.
hours triggers it to deliver a long term test.
Hmm. Hmm. Um, and then another question was is kind of a specific one. And so we'll go ahead and just take it. But they were saying they had a 100-year-old home with a gas furnace, radiator heaters. Would you do an assessment? I guess maybe the question is, you had meant, I guess you had kind of mentioned you have some subjectivity to your testing. Like if there's a radon concern, or if maybe there's what's it called? Ozone concern. But,
Mhm.
or are you kind of approaching this, the same in all cases?
Um, it's area specific, Brett. I know there's some areas where radon is a concern in certain parts of our local area. Largely, it's not. So,
Mhm.
if that customer has a specific request, then that may be something that we'll get into. Same thing for ozone, if it's a specific request. But
Yeah.
the data that we've collected just by doing
Mhm.
baseline testing, we found out that particles,
Mhm.
VOCs, humidity, temperature, all the ones that we discussed today are out of line hugely in just about every home or business that we step into.
Mhm. Mhm. Um, and on that note, there was a question here about testing for wildfire smoke. Now, you're in Southeast Michigan. I'm
Mhm.
here in West Michigan. I have no doubt that this is something we sadly will have to deal with at some point. We saw what happened a few years ago, right? When the wildfire smoke blew over just in the right wind patterns and made it pretty much, terrible here in Michigan. But
Mhm.
those are things people deal with, quite frankly. We've got California, as we're talking, mass evacuations going on. So do you have any thoughts about especially if someone's trying to forecast the future here, said, "Hey, Bryn, I'm concerned about elevated PM 2.5." And that can
Mhm.
come from, if I understand right, industry or heavy traffic too.
Correct.
How
Yep.
do you approach that?
So, it's funny you mentioned that. So locally, just a personal experience, when we were experiencing the wildfires, I believe last year, I set my monitor out, and in the house, my residence, I saw that I had elevated levels, and then I switched from a MERV 13 to a MERV 16,
Yeah,
and I saw that I was able to reduce those particles pretty significantly.
yeah,
So filtration, removing that PM 2.5 is critical. Having an appropriate filter. Now,
yeah,
before you deploy that, you have to verify that your ducts can accommodate that larger pressure drop. Because if you don't, you can
yeah,
damage your equipment.
yeah.
The ERVs, they come with filters on them to help reduce the particle intake coming from outside. And if a house is well sealed, that's your best chance of protecting you and your family.
Right. Yeah, yeah. No, I have installed MERV 16 before that happened and noticed the same experience,
Yep.
thankfully. So, but on that note, you mentioned the pressure drop. Now, there's a lot you read out there. People say that, a pressure drop, it's going to be awful. Then others people show studies that, it's not as bad as we thought. What are you seeing when you're actually out there doing the testing? And what kind of test is it to kind of verify? Do you actually just have the filters with you and you go, I'm going to pop in a 10, I'm going to pop in a 13 to 16. Let's see where that pressure is, because don't you have to test it with the actual level filter you plan to use in the system?
Absolutely. So that's a very good point. So Brett, what we do, we baseline our duct
Mm,
diagnostic with static pressure. We'll do a static pressure and airflow test, and
mhm,
then we'll see if the static pressure what it is. And the problem that we've run into, and I know we have data on that, especially in Southeast Michigan, we found that all of our duct systems are quite a bit undersized. So a lot of times when we implement a particle strategy and put an enhanced filter in, we do have to do some type of duct modification, and that's proven by static pressure. Static pressure is measuring the bursting pressure of an air handler.
yeah.
It's a proxy to
Mm,
airflow. If you have high static pressure, you
mm,
have lower than normal airflow.
mhm,
So before we attempt any kind of filter
mm,
upgrade, we kind of verify
mm,
that if the
mm,
system can
mm,
accommodate it. Oftentimes it can't. We have to make a
mm.
modification to the duct system.
Now, what kind of modification, I know a lot of ducts, they are number one, they're leaky. So you kind of went over that blown
Mhm.
in sealant. We did a whole webinar on that if anyone wants to check that out. A lot of time ducts are panned through joists, which, sadly, sometimes we still see sneaking into new construction and we have to try to weed that out. But a lot of older homes, they're panned through joists. And then, of course, if I understand right, you're talking about just length and run and diameter. What is typically are you seeing as the recommendations to fix the ductwork?
So the fundamental step is verifying that the equipment is sized appropriately, and
Hmm.
um, through surveys that we've done, we found that the HVAC equipment is typically grossly oversized
Yeah.
in residential existing structures. New structures I can't
Mm,
speak to, but structures we visit every day, I'll say more than 90% have a significant sizing issue. So
mm,
if the customer is going to leave that equipment there, we have to modify the duct, the plenum, and the trunk large enough to accommodate the airflow that's required for that system. And we
mm,
have to make it large enough so now we can accommodate that filter. So
mm,
having the duct modification, making the ducts larger, making a return duct larger, maybe changing some of the fittings to reduce the
mm,
equivalent length. Those are all things we practice to accommodate
mm.
like a filtration product.
Yeah, yeah. Um, Another question about maintenance came in, and I'm going to kind of expand on the question. The question was about, ERVs and HRV, being a concern because of they need to be maintained. And I've certainly heard similar issues like on a lot of the green building projects we do where they put in HRVs and ERVs. But just going beyond that, like, we put in these ventilation systems. They could be HRVs, they could be RVs, they could be simple filters, bath
Mhm.
fan cleaning. What kind of barriers are there to improving the ventilation systems if maintenance is not done right? Or is that something that you see more entities offering these maintenance services to make sure that they're actually being maintained well by people, especially if they're like located in certain areas where they're just difficult to access.
Very good question. Um, as a from a contracting standpoint, we do see the neglect
Mm,
with ventilation systems, where a customer
mm,
is out of sight, out of mind. They may not necessarily remember to maintain it.
mm,
They'll know when it's malfunctioning, and they
mm,
maybe notice a change in indoor
mm,
air quality. To kind of take it out their hands, a lot of times when we'll install a product, we'll actually offer to maintain it for
mm,
them. So that way, we're reaching out and we take kind of take custody of it, because
mhm,
everybody's busy and they're now focused on changing their filters in their ERV. Um,
mm,
one problem we do see with installations that we maybe personally didn't do, but we're maybe there for some maintenance is
mm,
to get the best performance
mm.
out of any ventilation system, like your HVAC system, the ducting has to be done correctly. It has to be sized appropriately. It has to be sealed, and in some cases insulated. So that's another thing that we need to look at. But we try to personally take the maintenance out of the customer's hands just so we can ensure that it's done.
Yeah, yeah. Um, there were some questions that came in here about radon a little bit, and again, I know very subjective, though. I will admit, we've seen radon zones, and I get the numbers mixed up, but I think three is the one that's not as bad. We've seen homes in zones three that have very heavily elevated radon, so I would never suggest anyone not still consider it. But the questions that kind of came in here was, you know, uh, have you seen people doing, radon tests and in conjunction with the other IAQ tests? Is that possible even to do that, in that short amount of time?
Yes, you can get radon specific equipment that has radon specific sensors in it.
Yeah.
And it just depends on your local
Mm,
area or market if that's something you want to offer. Again,
mm,
in our area is
mm,
not as prevalent as it is across the country. So it's just something
mm.
we haven't had a lot of requests for. But um,
Yeah.
I would definitely test for it if you're getting a new home and you want to
Mm,
verify that the radon levels are adequate. I would definitely test for it. But from a everyday IQ basis, it's just
mm.
nothing that we have to do yet in our market, if that makes
Yeah.
sense.
Yeah, yeah. So somebody mentioned that they were looking at your blower door testing in I think on one of your slides, 80, I think they mentioned, and I'm not sure what that is, but I think this the larger question is, are you typically looking at CFM or are you looking at ACH in what you do? And if you're not looking at ACH 50, why not?
So the ACH 50 takes into the house volume.
Hmm.
So we input the blower door, but it calculates ACH 50 on the back end.
Okay.
Yep. So it's not a we don't put the ACH 50 in. We put the parameters. Like if I go back here, it asks you for the height of the building,
Hmm.
and then it asks you for the floor area. That gives you volume. To get ACH 50 from CFM 50, you take CFM 50
No.
times 60 and divide
Yeah.
it by the house volume. So it has the inputs to calculate ACH 50.
Yeah. 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 Um, I obviously I see a lot of the work you're doing out there. You're out there training, well, first of all, I see you out there just encouraging people in this industry to improve and do better with the work that they're doing, and then doing the actual awareness and training and education and certification credentialing around it. Um, but it's still so rare to see an HVAC or weatherization contractor go in and kind of evaluate, air quality, but either on a short-term or a long-term basis and make it part of the conversation to do, testing of the systems correctly, to do, offering, maintenance work more than just the text message I get from my HVAC contractor that said, "Hey, do you need a test and tune?" Right? I get
Yep.
that one. And I'm like, "No, I need you to come out and do a measure quick on it." And like, "What's that?"
Yeah. Yeah.
So what my question to you is, what is how do we get this elevated, right? Like so that everyone is like offering these services, it's part of their package, and that someone doesn't just go, well, I'm going to go with the lowest bid who doesn't give me any information, right? Because seems like that could be the easiest approach for people to take. So
That's a very good point, Brett. I have a few comments about that. One is
yeah.
exposure. Um, I think it's not commonly done just because people are not aware. I think
Sure.
as an industry, we need to
Mm,
expose people more to the tools and technology that are out there and make training affordable and accessible for people.
mm,
So I think exposure and training is one.
mm,
As far as the general public,
mm,
when we walk in, we have to do a lot of educating. So to have the customers
mm,
understand to have them invest in these things that they should and we feel that there's
mm,
best, we have to help them understand that they have a problem. If they don't know that they don't have a problem, then they're going to go with that low
mm,
bid. They're not going to understand that
mm,
they're doing that. So a lot of communication, I'll say one of the best things I've done for from a
mm,
contractor
mm.
standpoint is actually understand how to communicate.
Sure. Yeah. No, that makes a lot of sense. So well, Brent, I really appreciate you taking time to do this, especially at the beginning of the year here. I know we went a little bit over time, so thanks for hanging out a little bit longer to answer some questions. I guess just as a reminder, or where can people go to learn about, you and what you're working on, and if they're trying to get training or education, where can they go to learn more?
If they want to visit us at www.hvactrain.com, that is
Yeah.
a the website for HVACU. You'll find different course offerings. You can reach out to us
Mm,
if you have specific needs for
mm,
training. We can discuss your needs and come up with a customized
mm,
solution. We have a lot of BPI courses for certification training. We have
Yeah.
indoor air quality
Hmm.
courses. We have a big push for heat pumps. That's a big incentive from the federal government. So you'll see a lot of training from that coming out really soon. But if they reach out to us, and then there's ways that you can reach out on the website and contact us directly, and then we can set up a meeting and chat about anything that you may need.
Yeah. All right, Bryn. Well, thank you so much for your time. And take care, the rest of you. We will see you next week, actually, to really continue this conversation on air quality metrics. So it was really good timing. So take care, Bryn. Thank you so much.
Take care, everybody.